shout out before I begin. Is this too loud, too hot? Can I, everything. Thank you, Glenn. Dark, Glenn in the back there. Quick shout out. Last year, Joe Kuttner came here to Big Ruby and did a presentation on his book, Healthy Program. I just wanted to say thank you to him. Following hardly anything of what he said in the book, I've still been able to lose about 20 pounds. No more sleepy afternoons, so check this book out if you sit in a chair all day long. It's good stuff. My name's Chris Morris. I'm a senior engineer at LivingSocial. And, in the last year we've had a little bit of bad press, so I figured we'd start off with some good press. Right now, this is from Tim O'Shaughnessy, our CEO, from an article in CNN Money, about all the great stuff that's going on at LivingSocial. And, best of all, we are hiring. Brian Owens, our VP of Engineering, is here. Glenn and Adam are talking tomorrow, and Greg Vaughn's in the house as well. So if you're interested in a new gig, or if you're not interested in a new gig and want to challenge us, come talk to us. So as he said, last year I did 2 lightning talks. I kind of like that format, so I didn't think they'd take me up on it, but here I am. So let's get going. So my first talk here today is to really encourage you as a developer to build things for yourself, not just for your end users. I'm surprised how often I'll see myself or other developers I'm working with doing a lot of repetitive manual labor in the act of creating automation. So a little background on my gig. Last summer, I took over as tech lead on our payment systems, which is primarily credit card, but PayPal and some other things. Our core payment systems does about 1.5 million API calls a day, credit card transactions upwards of 150K as well. The system's structured to be able to handle some of the big sales days we've had in the past. It's a big system, not terribly big. So, and it's fairly mature code base as well. So most of what my work entailed when I took this over last summer was doing production support. Due to PCI regulations, we can't have everybody in engineering on production consoles and databases and whatnot. So I got to do a lot of lookup stuff to help people out with crazy cases. So what I want to show you here is kind of a brief evolution of some of the console tooling I've built out. None of it's particularly impressive necessarily, but I wanted to share it just in case it was some inspiration to you as well. Use the computer you have in front of you. So here's your standard Rails output here. Don't worry, Ryan, this isn't production data. And a little difficult, to grok that. So after iterating on a few different things over a while, I was able to get that down to this. So one of the first things I did was to use pry. Pry may be one of those things you've heard about for a long time, like I had, but had never really used. And really there's no reason. There's no cost to get into using it. Out of the box, you'll get history retention that just works. You'll get pretty printing. So if you have an array of hashes, you can get something that looks a little better like that. And it's got a wonderful, massive tool set underneath that. So once you use it as your console, you can, you're brain dead, type help and learn a bit more about it. So another thing I did was to change using just the raw array that I get back from Rails and make this batch class with this method missing magic in it, which would just allow me to go from having to type map in these blocks, which gets a little old when you do it a lot, and then just be able to type in an attribute and have that pass through everything that's in that batch. Another thing that helped was adding a named constructor on this, because those finder methods, you can't autocomplete, so having something like this in there something like this in there is nice, because autocomplete can help you out there. One of the more obvious additions was throwing in text table, so that instead of messing around with left justify and trying to format this data in a console, you can just change it to be this and just choose the columns you want and then get some nice output here. Notice we don't have any column names there, so for that I leaned on the ActiveRecord serialization. The serializable hash method comes in really nice. It's got a nice API for deciding just the things you want. And so you can actually swap out that report method and just say, just give me these columns, give me a hash, and with a little bit of Ruby magic, you've got column headers. And for those paying attention, these aren't sorted. With a little bit more Ruby magic, you can get those sorted, but let's get that slide. So at this point, this is nice, but then I've got all this crap I don't really want to see, and I want to get just right to that table, so that's easy to deal with. You can override pretty inspect if you're using pry, and just by default, then get from there to there. Another thing that comes up, I'm usually researching something for somebody, and so I need to be able to email that out. And rather than going through Action Mailer and all of its stuff, you can just dive straight down to the mail gem and send out a quick little email message like that. I've also built out some similar batch functionality for Braintree, our credit card gateway. We love them. They're awesome. And because there are times when troubleshooting, we need to be able to compare our payment systems to Braintree's systems. and even repair transactions, void some stuff if we ever have brief outages or glitchery. So, and what's been useful about that stuff is, I built some of this stuff for myself, but over time, by just investing and iterating on this stuff, I'm able to come back later and either use it in production to solve production problems, or a lot of this stuff we'll be putting up as new endpoints in our API. So people who are in client apps of our payment systems can maybe go into their console and get some of that magic there for themselves. Real quickly, another thing that I've been working on. When I first came in there, we didn't have ready access to Splunk or one of the other log aggregators that we use. So really it was just shell scripting SSH greps out into machines across our environment. So I've built out a Thor command line script that I can use to go across all of our machines to get stuff out of there. It's got some of the typical options that you can just pass through to grep. And here's some of the scrubbed output from that. But on top of that, then, we output a lot of diagnostic stuff in each request, and so that creates kind of a lot of lines that interleave. So I've got a chunker in there that will parse those out, marshal all of those requests out to a file, and then with an optional pry command, pop that open in pry, and now I've got an array of actual requests that I can further filter down and further work through. And actually, now that when I started, I was like, man, I don't have Splunk, and now that I'm done, I'm like, I don't need Splunk, I'm good. So anyway, the point here is really to encourage you to do some of the same stuff yourself. I know sometimes when I'm building this automation, it feels like this. It feels like I'm that guy off on the side building the condiment passer. But as long as you iterate and release often, you can build big things with a lot of small steps, and it will definitely save you at least some time and probably come in handy in production later. The end of part 1. No. Please hold your applause until all the lightning talks have come to a complete stop. All right, my next talk, I don't want to brag too much. This one's scored me some accolades in my time. I also gave this talk at a job interview for Relevance, and you can see how that went. To be fair to JB, what he was commenting on, he was actually right. Anyway, a little bit of a background story. So LivingSocial acquired a company in the Middle East. If you want to do business in the Middle East, apparently you've got to pay attention to the large percentage of the population who still wants to use cash. And that's fine if you're shipping out product, which we do now these days, but for the most part we didn't. So we were literally shipping pieces of paper to people's doorsteps so that we could collect cash. So Glenn Vandenberg and I worked on a system that we needed to use internally for that. And so Glenn spun up a Rails app, and we called it, actually he called it Codmonger, which I thought was a funny name, and threw Factory Girl in it. So here's a very simple compressed view of the Factory Girl fixtures. We've got customers who have addresses, customers who have purchases. Each purchase has a collection, and the collection has a state machine that it goes through to run all of it through the collection stages. And so we got into production pretty quickly because we only had a few internal staff using it at that time. And so while working on it, I started with this RSpec that we needed. The details are not important. You can just see that right up here, I'm asking Factory Girl to give me a collection. And then I run the spec, and then it fails for this reason. And if we dig into the collection, it's actually pretty straightforward. We just needed the collection to have a purchase so we can access the customer, but there's no purchase. And when I went back to the Factory Girl code, that made me wonder, what the heck's going on, man? Just asked you to do that. So it wasn't the first time I'd run into some funky edge cases with Factory Girl, and I'd heard some good things about Machinist, so I actually just scrubbed it all. Switched over to Machinist. Same RSpec. We've got Machinist in their place. And same error, and same conundrum. What the heck is going on? Now, if you're like Hacker Gorilla, you may be asking yourself, why? If you're me, though, I don't care, frankly, at this point, because I know that I can just do this myself. So I ripped out Machinist and Factory Girl. Now, this isn't quite as sexy. It's not a DSL syntax and all that. And it's a few more lines of code. But guess what? It works. So anyway, the bottom line on this for me is okay, well, Hacker Gorilla still wants to know why. So we'll look at why. It took a while to dig through some of the internals to get at this. But basically, what's going on here is Factory Girl and Machinist are instantiating the ActiveRecord in 2 steps. So it's making it first, and then it's going through the trouble of assigning the attributes. Well, we had an edge case in this case. because our collection was using an initialized block on state machine that needed there to be a purchase in it. Now, this worked in production, but dealing with Factory Girl, and I know this is an edge case, and perhaps I'm picking on Factory Girl, but when I'm trying to figure out what's going on, this is one of the stack traces I'm faced with. I mean, there's 3 method missing calls. I mean, this looks like a word cloud from Java code. So kind of the bottom line for me is ActiveRecord's hard enough. I don't need your freaking DSL on top of it, okay? Oh. Hello, Ernie Miller, author of ActiveRecord DSL Squeal. I apologize. I think he forgives me. You know, Ernie's a good guy. Why don't I stand up and we can give Ernie a big Friday hug? I got my camera right here. Just kidding, it's Thursday, forget it. So anyway, if we compare my home-rolled version back over to Factory Girl, again, it's more lines of code. It's a little less syntax, but it's kind of clean. This is a pattern that I've started using myself. Basically just having a base fixture with a create method that calls out to new, and then for address, customer, purchase collection, they just have a new, and really all of the same code is in both versions, because really that code is focused on your domain, not on the action of creating this stuff. And this stuff is also easy to debug into, because unlike some of the DSLs, they have to do all their stuff at initialization time. On top of that, I mean, the source of the DSL is about 1 step removed from the runtime insanity that it's setting up on you. And so you kind of lose the benefit of it being open source. So what about Mocks? This part of the talk is subtitled, Not All Expectations Were Satisfied. I'm going to pick on Mocha for just a little bit here, because it's not Mocha's fault that our purchase ActiveRecord has that many fields. But when I first ran into this, it didn't word wrap, so that was not the most helpful error message in the world. And then this one here, I mean, this is just kind of like the drunk guy at the party who's been drinking who knows what, and then he goes for that piece of shrimp that's been sitting out on the buffet for 8 hours, and he puts it in his mouth, and then he just all over the floor. And you've got this crime scene. He's like, I don't know what went wrong, but you know, good luck and figure that out yourself. Mocha's nice. It's clean. You can do this, but other things are nice and clean too, like just using structs. Or if you don't like the separation between attribute name and value, you can use open structs, keep those things together. That's also nice and clean. You may be thinking, well, that's just a data object. What about behavior? Well, occasionally you can do some fun Ruby hacks by just defining a method on an instance if you've got a short little test, or, gosh forbid, use a class. So really, in this whole rant about doing it yourself versus using someone's gem, this is really the larger issue that we run into a lot of build versus buy. And my point is that when you're choosing buy, which is sometimes a valid choice, just know that you're trading in familiarity and transparency with what you're doing. We all build things. It's okay for us to build some custom stuff. Besides, all right, end of part 2. So track your big stuff. As I've mentioned, in addition to payments work, I've done some internationalization work, which came in really handy when I needed to make this slide for my Rails conference talk. So in our main monorail app at LivingSocial, which actually has been on a good diet, I think it's lost more weight than I have. At the time we were looking at this, we had about 2,500 translation keys, and we knew through some static analysis we only had about half of them in use. And we tinkered with using Ripper, which has got some cool stuff, but it just gets complicated fast when you're doing interpolation of key strings. So we took a look at doing this at runtime. And the biggest concern doing this at runtime is some of our requests have a lot of translate calls. And so we don't want to be writing off to a log or Redis 76 times a request and risking the performance hit just so that we can save a little stuff. Because it's not that big a deal to have that many keys in your app if you're not even using hardly any of them. But anytime we want to go into a new market and we've got to do all that translation work, that's when we start losing money. So after working on this for a while, we've come out with a tool that we were calling Humperdink. He can track a falcon on a cloudy day. So this was recently open sourced. A little disclaimer, some of the code in Humperdink is it's not what we're using in production. The core classes are, but my first run at it kind of was horribly coupled to the I18N gem, and really the core tech in it is not internationalization specific. So I just want to look through that code a little bit here. So one of the core classes here is a class called Dirty Set, which is pretty simple. It just encapsulates a couple sets called clean and dirty. And then anytime you're appending data to the set, then it's just tracking which stuff is dirty, which stuff is clean. You can reappend it. If it's already in clean, it's going to ignore it. You can also initialize it with whatever you had before. And so it's just kind of geared towards efficiently tracking only stuff that hasn't been tracked before. Now, at the moment, we only have persistence in Redis, but it would be simple to add additional backends that you wanted to put this in. So the Redis dirty set subclass is dirty set, and then anytime clean is called, it's going to write that off to Redis. Another core class in here is called tracker. Tracker is still trying to find its way in the world. It's kind of a glue, one of those weird. Hello. All right, so the tracker class here is designed to kind of fill in the gaps and also, most importantly, have some error handling here. We don't want any exceptions causing trouble when we're processing requests. We want that request to go through. If there's something wrong with the tracking code, we want the tracker to get out of the way. And so here's a sample for key tracking, and this is kind of the basic method here. Some of this probably needs to be reworked so that it's easier to reuse. But basically, if the tracker's still enabled, either because it hasn't broken yet, or we might disable it because we have performance switches that we can toggle features on and off with at runtime, then if it's enabled, go ahead and track that piece of data. And then here's another example showing that mixed into the IETN and backend class. So some configuration options. If we go back to dirty set, when it's appending stuff, it has this getting messy method that it'll use to decide if it's going to start moving things from dirty to clean. And here we've got two options, the max dirty items and the clean timeout. So you can either set a size or time threshold for deciding when to persist this stuff off. These two options, you can set them fairly high, and that works really well for any long-running processes like Unicorn. You might lose some if you've persisted and then gather some more data, and then you do a redeploy or something, and that process goes down. But we've had this running in production for weeks at a time to help make sure we hit all of the edge cases, so that's not a big deal. If you have rake tasks or cron jobs that are short-lived, and some of those other options don't work, you can either crank it down if you're not worried about performance, or you can use the add-exit block, although add-exit sometimes adds some headaches to the deal. If you're working with rescue is kind of a special snowflake in that it will have a parent process, and anytime it pulls an event off, it's going to fork and put that event down into a child process. And as a part of that, to help make sure things don't get weird, because the parent process may have exit hooks that it doesn't want triggering every single time it finishes an event, it will call exit bang, which is part of the kernel, which says exit, but don't run any of your exit hooks. So we were faced with short-running jobs that we couldn't persist the stuff off at exit time. So mixed into Humperdink is a module called fork piping, which will detect when it's in that forked state and then set up a pipe between the parent and child process. You can mix that in that way, one way. And then back to this method before, this gets enhanced so that it actually checks to see if it's forked or parent, and then just do the normal stuff. But if it's a child process, then it'll write that off to the child pipe, so that then you can configure your parent process however you want. And it's going to be long running, so probably you can just fall back on your size and threshold limits. This is a quick screenshot of Baskerville, which is our internal translation management app, written mostly by Greg Vaughn. And this is just a tracker view that we added. You could ignore those numbers up there because they're wrong, and that's my fault. But this is just a running list of strings that we have used and strings that we have not used. These colored squares over here are actually one per process where the tracker's involved, and they're all clickable and expandable, and they'll give you stats about each tracker, which came in handy when we were trying to roll this thing out. So real quick, another tool that we've been using for doing runtime tracking has been worked on by Dan Mayer, and he open sourced this recently, called CoverBand. It's in its early days and primarily is used for web processes. I don't think it has any support for backend stuff yet, but that would be simple to use. But basically, this is just the code coverage that you would have at test time, but at production time. And so at the moment, it's real straightforward. It's a middleware. This configure sampling line at the first part of its call is really just so you can set a percentage. So you probably don't want to do code coverage on most of your requests. You probably want to do them on very few. There's a coverage class in Ruby that Dan had worked with that was having some trouble with. So instead, he's falling back to use the set trace func and that's been working well. That gets called for each line and every file. So CoverBand has its own add file implementation that just stores that in a hash for the duration of the request, which gets run here. And then for report coverage, it just dumps that hash back to Redis. And when you're done, then since this is all on Redis on the back end, you can go grab that whenever you want. And Dan's written some code that'll output in the simple cov report format, so you can get code coverage from production. And it's actually pretty simple. So that's, again, been open sourced recently. I suggest you check it out. It's an awesome tool. That one actually is Dan, so I just point that out. Any bonus points for anybody who knows what band that is? That's a shame. I had a joke tied to that, so never mind. All right. So to wrap up, my last talk's a quick stroll through a whole bunch of different analogies that I've kind of collected. I'm a nerd, so I like to collect these kinds of things in my homegrown wiki, which I wrote in Ruby 1.6 and is now hosted as a Rails 4 engine. It's a real Frankenstein of technology. It's awesome. So anyway, if we're going to talk analogies, we got to start with an obvious one, and that's the construction analogy. Now, many of you may be groaning. Many of you hate this analogy, probably because we frequently use it to shame ourselves. Anytime something goes wrong, we're like, you know, those construction guys have got this stuff all figured out. I don't know why we can't get our stuff together. It's actually a decent analogy if you apply it correctly, and that usually falls down in two ways. One is that the code is actually the design. We like to think of the plans and pretty pictures are all the design, and then the grunt work's done by the coders. This concept, as far as I know, was first introduced in a C++ journal article called What is Software Design back in the 90s. And then Glenn has a great talk called Real Software Engineering, where he does a deep dive into all this, so I highly suggest you check it out. And the other problem here is that we kind of presume that the construction industry is awesome when in fact they struggle with the same kinds of scheduling stuff that we struggle with as well. Back in 2002, Mary Poppendike went to a construction seminar on like how to do master planning and told them, she's like, yeah, I'm a software developer because we've been told that you guys have this all figured out. And they like nearly laughed her out of the place. So just two of the common problems they run into is materials that are waiting for workers or workers that are waiting for materials. And while we probably have less of that kind of issue, although I'm sure a lot of us have spent time sitting at a desk waiting for a computer or waiting for some server to be spun up, they have the same kind of problems as well. The Pride guys prefer to the construction analogy that of a garden. Say with a garden, there's a constant assumption of maintenance. Luke Holman goes on with this. He says, there is an overall plan, but the result requires more tending. And why does software require tending? Well, things shift. If you think about all the gems we use, all the tooling, databases, OSs, they all need upgrades. They all need security patches. Our hardware will fall down. We're renting clouds and whatnot. And so we have scaling issues, and all those things shift the landscape, so it makes it unpredictable. That's one of the reasons I think people like the construction analogies. They think, well, that building's done. We don't have to do it anymore, but we all know when we write software, the thing's only begun. Of course, with buildings, too, they actually go through that as well. So Jim Highsmith prefers the analogy of climbing to help bring in the notion of risk management. He says, in climbing, one continually evaluates the margin of safety, matching the objective and current conditions with the climbing team's capability. Bill Tuccio likes the analogy of flying. The overall flight plan is important, but the exact route to be followed cannot be defined due to changing conditions. In fact, certain conditions can't be known until you're underway. And if you delay in an effort to acquire requirements that are so absolute that the path is completely defined, you'll never depart. Test-driven and refactoring is a lot like working in a professional kitchen. Michael Feathers wrote about this back in 2005 after watching some of these cooking shows on TV. One of the commenters on his article recalled his own experience in a kitchen saying, clean as you go wasn't so much a suggestion, but rather a law. Those workspaces of cooks who didn't constantly clean would become so messy that the quality of food rapidly diminished. This problem would progress until the other cooks were forced to step in and clean up. Coding without tests is kind of like playing chess without having a computer to analyze your lines. Now, that's not very sportsmanlike, but we're not in it for the sport. We just need to use the computer to increase the feedback and visibility into our code. Adding new features to your software is a lot like adding a baby to your family. Internationalization is a lot like polygamy. Software development is kind of like clearing some land. The first solution you've coded through a problem clears a path from A to B, but the work's only begun. If you stop there, users are likely to wander into other parts of the field. And what's tricky from a cost-benefit perspective is deciding how far off that path you need to go to allow users, or what kind of constructions you need to build to keep them in the clear. Although that analogy kind of suffers because it presumes that you've got this nice flat 2D field that you can see everything. So it's a little bit more like carving tunnels through a mountain. And each new tunnel can unexpectedly intersect with another one, cause cave-ins. And so automated testing can help us explore these tunnels to help make sure there's not problems there before our users find out there are. People like Martin Fowler talk about hiring experienced developers with broad knowledge for the same reason you'd probably want to have experienced explorers like Lewis and Clark. The explorers, not Lewis and Clark, the evil bunny duo. Thanks, Google Images. Every project is unique, and it's like unexplored territory, and no one's built this particular system with the same combination of tools, domain, and people. So the process of exploration is going to yield unknown obstacles, and you need people who know how to adapt in the face of the unknown. This also reminds me of a great answer that was given on Quora by Michael Wolff to why software estimates can be often off by a factor of 2, 3, or more. He uses the analogy of planning a walk from San Francisco to LA. And when you start at a high-level Google map, you think, yeah, I can probably knock that out in about 10 days. Then you start off on your first day, and then you realize, the map's got a lot more contours in it. But then, of course, you meet actual reality, and you think, that's nothing like what's actually on the map. This is a nut processor from a farm in Banks, Oregon. And I think it may capture what we do the best. We're not operating machines like this. We're designing virtual ones. We're map-reducing raw data into the stuff dreams and hopefully profit are made of. Anytime we want to make a change to our systems, even a small one, we're potentially affecting the flow of a lot of nuts, and no one wants to be sweeping those things off the floor. So we're almost done, but there is one more ultimate analogy that we can mention, and that is the meta-analogy. That developing software is like creating an analogy. We're modeling reality in our own virtual world of nerd awesome, making things that are like other things. Is that too much? Yeah, I think so. So, the secret of comedy, timing. All right, so we reached the end of this talk, and after all of these talks, if there's one takeaway that I'd like you to all take away, it's that we're hiring, and I get a bonus for every referral. So thank you very much.